Let's discuss maximum and minimum values. Let's start with the definition of global extrema. The absolute greatest or least value of a function is called its global maximum or its global minimum. The more formal definition is a global maximum occurs at x equals c if the function evaluated at c is greater than or equal to all other values of the function. A global minimum occurs at x equals c if f evaluated at c is less than or equal to all the other values of the function. Collectively, we call the global maximum and the global minimum values of a function global extrema. Let's take a look at the global extrema graphically. The absolute greatest or least y value of a function is called the global maximum or the global minimum. Let's take a look at the definition of local extrema. The greatest or least value of a function over a given open interval within the domain of a function is called the local maximum or the local minimum. More formally, a local maximum occurs at x equals c if the function evaluated at c is greater than or equal to all other values of the function near c. A local minimum occurs at x equals c if f evaluated at c is less than or equal to all other values of the function near that point. Collectively, we call the local max and the local minimum local extrema. Let's take a look graphically at what a local extrema looks like. The greatest or least y value of a function over a given open interval is called the local maximum value or the local minimum value. Now, as we look at this graph, we can see that we have a local and global maximum at the graph's highest possible point. We have a local and global minimum at the graph's lowest possible point. But we also have just a regular local minimum and a regular local maximum. These 2 points represent high and low points of the graph, even if they're not the highest or the lowest point of the entire graph. Let's take a look at the definition of critical points. Critical points occur on the original function at any x value where the tangent line drawn through that x value is horizontal, vertical, or does not exist. More formally, critical points occur for any function f at the point c in the domain of f where the derivative evaluated at that point is 0. This would relate to a horizontal tangent where the slope of the tangent line would be 0. Or the derivative evaluated at that x point is undefined. This would relate to being either a vertical tangent or non-existing. Let's look at critical points graphically. In this first function, if we were to draw a tangent line through the red point, it would be a horizontal line and its slope would be 0. This is the first case where the derivative evaluated at that point is 0, which indicates a horizontal tangent line. These next 2 examples illustrate the 2 other cases where the derivative is not defined. In the first case, the tangent line would be vertical through the red point, and in the second case, this function is not able to be differentiated at that sharp point, so the tangent would be undefined. Let's talk about how we actually go about finding critical points for a function. Let's say we have f of x equals 2x cubed minus 3x squared minus 12x. In order to find the critical points, we have to determine where the slope of this function's tangents are either horizontal, which means the derivative is equal to 0, or vertical or do not exist, which means the derivative is undefined. So it's a 2-step process in order to find these critical points. So we would begin by actually finding the derivative of this function. The first part is to say that the derivative has to be 0, so the derivative of 2x cubed minus 3x squared minus 12x is 6x squared minus 6x minus 12. We will set this equal to 0 and now do some algebra in order to solve for x, and we're going to end up with x equals -1 or x equals 2. So the answer to part A here is that the derivative is equal to 0, which means the slope of the tangent lines are equal to 0, which means we have horizontal tangent lines that would be drawn at x equals -1 and x equals 2. Now the second part of the definition means we have to check the derivative to find out any places where it does not exist. Well, back to our derivative, f prime of x equals 6x squared minus 6x minus 12, there isn't any place on the domain of this function where x does not exist, so the derivative exists anywhere, so the only critical points would be the first two that we found. Let's take a look at where these are graphically. Here we have a point graphed at x equals -1 and x equals 2, and you can see that if we drew in the tangent line, in both cases it would be horizontal.